We're now going to take a look at how to program with parallel fluxes. This will be important for one of the upcoming programming assignments. So let's take a look at the case study. This case study shows how to use parallel fluxes to multiply and add big fractions, both asynchronously and concurrently, using a whole slew of Project Flux operators and some ParallelFlux operators, as well as the scheduler's parallel thread pool. So let's take a look. It's in the ex5 project in my reactive Flux folder in my live lessons GitHub repository. Here we are in that live lessons repository. Let's take a look at the entry point into this test program. You can see that we've got 3 methods under test here. We have test fraction multiplications 1, test fraction multiplications 2, and test parallel downloads. So I think we're going to start off by taking a look at test fraction multiplications 1. This method will first create a big fraction array with numerators and denominators, as you see here. We then turn that into a flux, turn that flux into a parallel flux, run this on the parallel thread pool, which we get from scheduler's parallel, and then we're going to multiply everything together. So all these multiplications are going to take place in parallel. We're going to multiply everything by some big reduced fraction, and then we convert the parallel flux back into a flux by using sequential. And the final thing we do is we display the results. So that's a very straightforward way of doing things. You can see that this looks roughly equivalent to parallel streams, a little teeny bit more ceremony going on here, but it's really not that much. Let's go take a look at test fraction multiplications 2. Same thing, we create a big fraction array, except this time for kicks, we're going to make ourselves a consumer that will be used to display the results incrementally as we go along. And then we create a stream of big fractions, turn that into a parallel flux, run that on the parallel scheduler. And now we're going to go ahead and reduce everything by multiplying it by a big reduced fraction. We multiply everything together. We then log the big fractions. And then the final thing we do here is we use the reduce operator. You can see what reduce does is it takes everything that's been running in parallel, and as they complete, one thread, typically the final thread that is used to do the multiplication, will then go ahead and add all the results together. That returns a mono, which will emit the results of doing the additions of all the multiplied big fractions. We then display those results, if all goes well, by using this display results consumer. And then we return the mono to void. Remember that the then method returns a mono to a void, which is a suppression operator that will be used by the async task barrier framework to synchronize with everything. So those are a couple of the methods that we see here. You can see that using parallel fluxes makes it really simple to do this in parallel without having to do the somewhat convoluted flat map concurrency idiom. We'll now go ahead and run the test program to see the results of test fraction multiplications 1 and test fraction multiplications 2. It compiles everything, and then it runs. And you can see here, when we run this, this is the results of the fractions when we multiply them together in parallel. And here's when we multiply everything together in parallel, and then we sum the results. So those are the results from the first 2 tests.